The next topic is the solid of revolution using disk method. Well, suppose you have a curve like y equals to f of x, and you start rotating this along x-axis. Okay, when we rotate this along x-axis, this is the 3D object that we're getting in the space. But how do we find the volume? To find the volume of this object, the most important thing is the cross-section, which is a circular shape. The circular shape has area that you learned before. It's pi r squared. So this circular object here with radius r has area which is pi r squared. Now take a look at this moving circular object in this 3D shape. This is basically circle. So the area is pi r squared. But what is r here? When you want to calculate r, your r is changing. Take a look from the smallest r, and it starts increasing, increasing, increasing. So r is changing. R is changing as x start increases to the right-hand side. This r is nothing but f of x, the function itself. So a of x, which is the area of this circular object that is moving, is pi f of x squared, because r is f of x, r is changing, and then you take the definite integral with respect to x. So this is the idea of using disk method. As you can see, your cross-section is a disk. So since it's a disk, the area of the disk or the circular object is pi r squared, but r is changing. R depends on the function f. Very good. Then highlighting r to be f of x, r squared is f of x squared. Example for you. The region between the curve y equals to square root of x, while x is bounded between 0 and 4, and the x-axis is revolved about the x-axis to generate a solid for us. Question says, now find the volume. Well, how do we find the volume? Visually, this is what we have. F of x is equal to square root of x, which is this guy here. And assume I just show you one part, one piece for the sake of the space. I bounded x is between 0 and 1 to show you how this visually can be represented. But in our question, it says, hey, extend it to 4. Okay, we don't have any issue there. But my object here, for the sake of space, is just between 0 and 1. As you can see, when we rotate this guy, square root of x, about x-axis, this is the 3D object that you're getting. So remember that we need to find the cross-section. But the cross-section, as you see, is just a circular object, this circular shape, which is in purple, and it is moving. It starts from the smallest value, which is the origin, and starts increasing toward the right-hand side. So basically, you are taking y equals to square root of x, or you're taking this curve and rotating it about x-axis. Very well. The cross-section, as you can see, is this circular object. All right, here we go. Or the disk that you see here, but this disk is just a random cross-section. It starts from the origin and start moving to the right-hand side. So basically, since you have a circular object, you're interested in finding the area of this object, but the radius is located on the curve square root. So the volume can be calculated as the definite integral a to b of pi rx to the second power dx. What is r? What is the radius? Radius is square root. Then you're going to raise it to the second power, and x is bounded between 0 and 4 as the question mentioned. Perfect. So the rest should be easy for you. This is the definite integral of pi, and square root of x to the second power is just x dx. Using the technique of integration, this is pi, x squared divided by 2, and x ranges between 0 to 4, which is pi 4 squared over 2, or 8 pi. So the volume of this object that we rotated about x-axis using the elementary knowledge about the area of a disk or area of a circular object can be easily calculated, and it is 8 pi.